Welcome to This Explainer. I am so glad you're here. Today, we're diving into a piece of everyday engineering magic that's literally sitting inside your car right now, ready to save your life. We're talking about ABS, or Anti-Lock Braking System. It's a tech that totally transformed how we drive, but honestly, most people have no clue how it actually works. So we're going to break it all down in super simple English. By the end of this, you'll be an absolute expert. Let's get right to it. Here's our roadmap for today. We've got 1. The skidding problem. 2. The smart parts. 3. ABS in action. 4. Pros, cons, and myths. 5. History and fun facts. And 6. A simple conclusion. Section 1. The skidding problem. Why we need a hero. So to really get why ABS is so incredible, we first got to understand the terrifying problem it was actually invented to solve. Picture this. You're just driving along normally, right? Everything's fine. Then suddenly something jumps out into the road. Have you ever had to slam on the brakes in an emergency like that? You're going fast, maybe the road is a little slick, and you just mash your foot on that brake pedal as hard as humanly possible. It's your very first instinct, right? Stomp on the pedal? Well, in an older car without our technological hero, that instinct could actually get you into some serious trouble. Here's exactly what happens when you slam on the brakes in an older, normal car. Your wheels experience something we call locking up. Locking up just means the brakes clamp down so hard that the wheels completely stop turning. But the car is still moving forward. When the wheels stop rolling and just drag across the pavement, you start skidding. And when you're skidding, you're just sliding forward, completely out of control. Think about walking outside in the dead of winter. If you step straight down on an icy sidewalk, you're usually okay. You have grip, or what scientists like to call static friction. But man, the very second your shoe starts to slip, you completely lose that grip, and suddenly you're sliding everywhere. It is so much harder to stop once that sliding starts. Well, the exact same thing happens to your car's tires. Once they lock up and start to slip on the road, their grip massively reduces. There's a perfect quote that sums this all up. A locked wheel is like a ski on snow. When your wheels are locked up tight, they absolutely do not care which way you turn the steering wheel. You could spin that wheel all the way to the left, all the way to the right, desperately trying to dodge whatever's in front of you, but your car is just going to act like a pair of skis and slide straight ahead into danger. Bottom line, to steer a car, your wheels absolutely must be rolling. Section 2. The smart parts. Meet the mentors. Okay, so how do we stop the wheels from locking up so we can actually keep our steering? Enter our hero, the Anti-Lock Braking System, or ABS. But before we meet the computer brains, let's just look at the basic muscle of your car's brakes. Right behind your car's wheel is this metal circle called a brake disc. It spins right along with your wheel. Straddling that disc is a clamp called a caliper, and it holds 2 brake pads. When you press the brake pedal, that caliper squeezes the pads against the spinning metal disc. Think of it exactly like pinching a spinning plate between your fingers. The harder you pinch, the faster it slows down. But if you pinch too hard, the plate completely stops, and boom, that's a lockup. So how does ABS upgrade that basic system? Well, it adds 3 main smart parts. First up, we have the wheel's speed sensors. These are like little watchers attached to every single wheel, constantly measuring exactly how fast the wheel is spinning. Second, we have the electronic control unit, or ECU. This is the computer brain of the car. It's sitting there taking in all the messages from those watchers. And third, we have the hydraulic modulator. Think of this as the intelligent muscle. It's basically a pump with these tiny valves that sits right between your brake pedal and the wheels, totally ready to take over the brake pressure if things start going wrong. Section 3. ABS in action, the climax. We've met the parts, so now let's see them work together in this amazing chain reaction during an emergency stop. Boom, you slam on the brakes. Step 1. Those speed sensors notice that one of your wheels is slowing down way too fast. It's got to lock up. Step 2. The sensor yells to the ECU brain, hey, we're about to skid. Step 3. The brain instantly commands the modulator muscle to step in. Now, even though your foot is mashing the brake pedal down to the floor, the modulator briefly releases the brake pressure on that specific wheel. This lets the wheel start spinning again so you get your grip back. Step 4. Just as quickly, the modulator clamps the brake back down to keep slowing you down. But the real magic of a computer here? The system doesn't just do this release and clamp action once. No way. It can do this rapid pumping action 20 times or even more in a single second. It's this super fast, perfectly timed dance between the sensors and the brain. I mean, there is absolutely no human being on Earth, not even the best professional race car drivers, whose foot can pump a brake pedal that fast or that perfectly. The computer is modulating that pressure multiple times in the time it literally takes you to just blink.
Let's compare what this actually looks like, because honestly, this is what saves lives. Imagine a car without ABS slamming the brakes. The wheels lock, the car basically turns into skis, and it slides straight into whatever is in front of it, even if the driver is desperately turning the wheel. But with ABS, because the system is pumping those brakes 20 times a second, the wheels never fully lock. They keep rolling just enough to maintain grip. This means you can hit the brakes as hard as humanly possible and still turn the steering wheel to gracefully and safely swerve right around the obstacle.
Section 4. Pros, cons, and myths. The realities. Now, ABS is absolutely incredible, but we gotta be real about what it can and cannot do. The absolute biggest pro, like we just saw, is keeping your steering control while braking hard. That is a massive, massive advantage. Also, on dry pavement, it can often help you stop in a shorter distance because it keeps your tires at the absolute perfect threshold of grip. But there are limitations. ABS cannot defy the laws of physics. If you're driving way too fast around a really tight curve, physics is still gonna win and you're gonna slide off the road. Also, on super slippery surfaces like pure ice or loose gravel, ABS might actually take a slightly longer distance to stop. But, and this is super key, it will still keep you steering straight instead of spinning out. Okay, we really need to bust a myth right now because this is something maybe your parents or your grandparents taught you. The old myth goes, if you start sliding, you should manually pump the brake pedal yourself with your foot. Well, if you have a modern car with ABS, that is totally false. If you pump the pedal yourself, you actually confuse the computer. The absolute fact is, you must press the brake pedal down firmly and hold it there. Do not let go. You might feel the pedal wildly vibrating against your foot, and you might hear a really loud grinding noise. Don't let it scare you. That vibration is just those hydraulic valves working 20 times a second. Just hold your foot down hard and steer. Section 5. History and fun facts. The lore. So now that we know how it works and exactly how to use it, let's take a quick look back. How did we even get this tech in our cars? What's kind of mind-blowing is that the idea of anti-skid actually started with horses. Way back in the 1800s, carriage drivers realized if a carriage skidded, they had to loosen the horse's reins to let the wheels roll again. Then, in the 1920s, early airplanes were having huge problems skidding on runways, so engineers started designing mechanical anti-lock brakes for planes. By the 1950s, a system called the Dunlop Maxaret was stopping military jets safely. And finally, thanks to the invention of tiny electronics and computers, Mercedes-Benz introduced the first digital ABS system for passenger cars in 1978. It was a complete game changer. And here's a really cool fun fact. Remember those wheel speed sensors we talked about? Well, once car makers put those sensors on every wheel, they realized they could use them for all sorts of other tricks. Like, if you press the gas pedal way too hard on ice, your wheels will spin out, right? Traction control uses those exact same ABS sensors to detect that spinning and slightly applies the brake so you can grip the road and move forward. Electronic stability control goes even further, braking individual wheels to stop your car from spinning out in a tight turn. ABS is basically the grandfather of all modern car safety tech. Section 6. A simple conclusion. We've covered a lot of ground today, right? From slipping on ice all the way to jet airplanes. So let's wrap this all up into a neat, simple package so you can remember it forever. Here are the golden rules of our beginner's guide. Number 1, ABS stops your wheels from locking up and turning into skis. Number 2, it does this using a brilliant team, wheel speed sensors acting as watchers, a computer brain making the choices, and a hydraulic pump doing the heavy lifting 20 times a second. Number 3, because the wheels keep spinning, you keep your ability to steer away from danger. And lastly, if you are ever in an emergency, just press the brake pedal down firmly and hold it. Let the computer do the fast pumping for you. I want to leave you with this final thought. We hop into our cars every single day, totally taking for granted the millions of lines of code and the thousands of sensor readings happening every single second just to keep us perfectly safe on the road. So next time you hit a patch of rain or snow and you feel that weird, loud pulsing under your foot, don't panic, just smile, keep your foot down, and thank the brilliant engineering of ABS. Thanks so much for joining me for this explainer. Stay safe out there and never stop learning.